Hey, in this tutorial we're going to look at general solutions to trigonometric equations. Okay, so in previous videos we looked at specific solutions where we were given a domain. Now we're looking at general ones where we're not given a domain, so we have in fact an infinite number of solutions. Okay, so the first one that we'll look at is if sine of theta equals a. Okay, then theta equals 2n pi plus inverse sine of a, or 2n plus 1 pi minus the inverse sine of a, where n is an integer. Okay, so I'll just go through what this means. Okay, so this 2n pi means that we're going to be looking at our angle in the first quadrant. Okay, so this part is going to give us our basic angle or our reference angle. Okay, and this means that we're always going to be in our first quadrant. So if you think about it, if n was 0, then all of this is 0 and we're just our basic angle. Okay, and we're in our first quadrant. Okay, if it was 1, okay, then we're going to have 2 pi plus this. So that's going to be a rotation around and we're still going to be in that first quadrant. Okay, of course, we need one that puts us in the second quadrant. Now remember our second quadrant, okay, over here, we always find our angle by going pi minus our basic angle. Okay, so this time we need multiples of pi. Okay, so this is where we get our 1, okay, in here with our 1 pi. Okay, that's here, but we always need to add multiples of 2 pi to it as well, and that's what happens with this 2n. Okay, so if n is 0, we're still going to get pi. Okay, minus this basic angle again. N's 1, well, we're going to be at 3 pi, so that's 1 loop around again. Okay, now sine is the most complicated. Okay, our other two are a little bit easier. So if cos of theta equals a, then theta equals 2n pi plus or minus inverse cos of a. Now that's just because we're in the first and the fourth quadrant for cos being positive. Okay, and this angle in here is the same as in there. Okay, and that's why we can do plus or minus. Okay, so this will be if again n was 0. Okay, then we're going to be, our plus will be our basic angle up here. Our minus will be measuring our angle back this way, and we still get the same thing. Okay, and again, if we make n 1, okay, then we're going to go around full time for both those solutions. Okay, if we look at tan, tan's even easier again. Okay, because remember we're first and third quadrants, so only a difference of pi between them all the time. Okay, so we can simply say if tan theta equals a, then theta equals n pi plus the inverse tan of a. So this is again our basic angle. Okay, and if n was 0, okay, then we're going to get this first one. Okay, if n was 1, we're going to get this second one, and so on. Okay, so that's how we find them. Okay, but we really need to see these in a couple of examples, which I've got ready to go here. Okay, so I've got a few different worked examples we're going to have a look at. Okay, the first one, okay, is find the general solution to cos of theta equals a half. Okay, so the first thing we always need to do is what's our basic angle? Okay, and that is when does cos equal a half? Cos equals a half at pi on 3. Okay, so this bit is our inverse cos of our a in our equation before. Okay, in our general solution. Okay, because this is our a value here. Okay, so we've got our basic angle now, so now we can just look at our general solution. So then we've got theta equals 2n pi plus or minus our pi on 3. Okay, now most of the time they don't like you leaving it like this, so we've got to do a little bit of work. Okay, and we can say then that this would be 6n pi on 3 plus or minus pi on 3. Okay, so then we can say, come up over here, we've got 6n pi plus or minus pi all on 3. Okay, they want to see something where you've done a little bit of work to put them together. Okay, so there's different things like that we need to do. Okay, we're just bringing together to neaten up our solutions a little bit. Okay, now of course we could look at splitting this into two solutions. Okay, plus pi, okay, on 3, or 6n pi minus pi on 3. Okay, so that's what we'll be looking at for our first one. For our second one, okay, we want to be doing finding the general solution to sine of 2 theta equals 1 on root 2. So again, we need our basic angle. So that is, when does sine equal 1 on root 2? It is pi on 4. Okay, so then we're going to do the same thing. So we need to look at our solutions for sine. So we've always got two of them. Okay, so we say, but this time instead of saying theta, we need to say 2 theta. So we say 2 theta equals 2n pi plus our basic angle of pi on 4, or 2 theta equals 2n plus 1 pi minus our basic angle. Okay, so again, we can fix these up a little bit and say 2 theta equals 8n pi plus pi on 4. Okay, and so what we can do here, I probably should have done it up there. We can make this look a bit nicer too. Okay, well of course we're going to divide here, but before we get to there, we'll say 2 theta equals, we can take pi out as a common factor, so we've got pi outside of 8n plus 1 on 4. Okay, and we can divide by that 2 and say theta equals pi outside of 8n plus 1 on 8. Okay, so we could have done a similar thing over here, taking our pi out, okay, and had pi outside of 6n plus 1 on 3, or our 6n take 1 on 3. So we should have done that before. Hey, so here we need our other solution, okay, which is going to be 2 theta, okay, equals, now we're going to be 4 outside of 2n plus 1 pi, take pi on 4. Okay, we just need to make them all the same. Okay, so we say 2 theta outside of 4 outside of 2n plus 1 pi minus pi, okay, on 8, and pi outside of, we can expand this out a bit, okay, we can say 8 n plus 4 take 1, okay, on 8, okay, or theta equals pi outside of 8n minus 1, so minus 3, so, or plus 3 even, so 4 take 1 is of course 3 on 8. Okay, so that one's getting a little bit squished at the end there. Okay, and our last worked example is find the general solution to sine of 2 theta plus pi on 6 equals root 3 cos of 2 theta plus pi on 6. So hopefully from doing some of your previous work, you will have realised that the process here would be to divide by cos, okay, to both sides, turning this one into tan. So first thing we need to do, turn into tan, 2 theta plus pi on 6, okay, and we're going to be left with, on this side, just root 3. Okay, so our basic angle, okay, so when does tan equal root 3? And that is pi on 3. Okay, so it's pi on 3 that we're looking at here. Okay, so now we need to look at our general solution, okay, which for tan is theta equals n pi, okay, plus, that's our 2 theta plus pi on 6, of course, okay, because it's whatever's in here, okay, equals our n pi plus pi on 3. So then we can say, well, we've got 2 theta plus pi, actually, we'll just do our 2 theta at the moment, equals n pi, okay, plus, we're going to be just pi on 6 now, because this would be 2 pi on 6. Okay, take away a pi on 6 is going to leave us with a pi on 6. Okay, so then we can say 2 theta okay, equals 6n pi plus pi all over 6. So theta equals 6, or I would say pi, sorry, outside of 6n plus 1, we may as well, on 12. Okay, so we're just taking the pi out as a common factor, okay, and divided by our 2 as well to give us 12 on the bottom. Okay, so once you see those general solution equations, okay, they look quite different once you actually start using the equations. Okay, you can see that we're actually subbing in values, okay, and rearranging, collecting like terms and different things like that. Okay, so hopefully those examples will be enough to get you through your questions.